Allow me to make the announcement that the current boiler video that you're about to view was not recorded at this current time and date. It was actually recorded back in May 5th, so I figured I would put forth this brief intro to let people know the current time frame and the date that this boiler video was made. In addition to that, I do have another boiler video. This will be a video that you're going to be watching that pertains to the unit that actually heated up my place of residence of where I used to live. And the following video I'll be having, or the final boiler video I'll be having on the Scotch Marine commercial grade boiler, will be a complete gas operation of that boiler and burner. That video I might have up within the next week or so. I might post it sometime shortly after this. Now on another note, I just want to briefly say something, because on some of these boiler videos that I've made, I've been getting some negative comments, or pretty much one pertaining to the heat timer, the platinum heat timer. Now, I will say this much. I don't mind if people post comments that disagree with what I say in the video. However, I've been getting, or there was one comment that I've received where someone tried to pretty much make it seem as if I didn't know what I was talking about. I was unknowledgeable of the platinum heat timer, even though I've been running it for damn near 10 years. And also tried to promote their websites or their blogs or forums on my comment thread after pretty much trying to belittle me on my own damn content. Now, once again, I don't have a problem if people disagree with me. But the one thing I will not stand for is somebody coming to my comment thread trying to tell me I don't know what I'm talking about. Tell me I don't have an understanding of what it is that I'm speaking of. And yet at the same time trying to promote their websites, forums, or blogs on my comment thread. That's what you have your own YouTube channel for. This dude even went as far to say I created the channel for the sole purpose to come to my comment thread to tell me that he disagrees with me and pretty much that I don't know what I'm talking about. When I get comments like this, these comments will be blocked, deleted, and you will be banned from my comment thread, and you will no longer be able to post comments if you come back to my, or if you come to my comment thread leaving me ridiculous comments like this. Now, for those who are under the impression that I don't know what I'm talking about, allow me to say that I've been doing this for many, many years. I don't need anybody's validation to tell me that I don't thoroughly understand a one-pipe steam heating system, because in the video that you're going to watch shortly after this intro is a system, a one-pipe system that I built from scratch. So with that being said, that's just one reason alone why I can get on camera and I can say the things that I say when it comes down to that topic, because I understand it. It's a technology that I've been studying since I was a kid. It's something that I've actually done my own experiments on to come to my own conclusions and understandings of how it works. So the last thing I'm going to tolerate is anybody coming to my comment thread trying to tell me I don't know what I'm talking about. Now, but on an ending note, that video with that platinum heat timer, what I was doing in that video is showing people how to sufficiently run steam heating systems on one-pipe steam systems. The best means of methods when it comes down to actually producing steam, steam delivery, and sufficiently supplying steam and satisfaction of steam on a one-pipe steam system. It's not about making everybody comfortable, because that's something that you can't do whenever you're running a large residential building on a one-pipe steam system. The only time you can actually make, or every tenant, each apartment can be as comfortable as you want to be, is pretty much when you have an air handler unit, just like what I got sitting right here, which hot water flows through it in the wintertime when it's needed for heat, and then you have a switch where you can turn on the air conditioning in the summertime. Now, depending on how the system is set up, you'll be able to run heat or air conditioning throughout any time of the year, or you'll only be able to run specific things throughout a specific time of the year. That is the only way you can do that, because pretty much how this works, there's a switch inside of there with a thermostat. You flip up the latch, turn the switch on, or press the button, adjust your thermostat, and you get the temperature that you're desired for the room or location, apartment, unit, whatever it is that you're heating or cooling. Whenever you're dealing with a one-pipe central steam heating system, or even a hot water system where it's controlled, operated from a single control, whether it be a platinum heat timer or a thermostat, you're never going to be able to satisfy the apartments the way everyone wants to be satisfied. So pretty much what I'm explaining to people is how you stay above the law. Make sure you're doing what's required by law, because here in New York City, the law states that when the temperature drops below 55 degrees, Anytime past from 5 a.m. to 10 p.m., the temperatures must be kept or maintained of a minimum of 68 degrees throughout the daytime. Beyond 10 p.m., if it drops below 40, you have to maintain a temperature of 55 degrees. That's what the law states. So pretty much what I'm doing is I'm cutting out all the unnecessary bullshit and showing people how to pretty much run it and remain above the law, and that way you stay clear out of having complaints. Now the one thing is running running two boiler systems for over 10 years, I've had numerous inspectors come by because people made complaints, but the one thing the inspectors can never do is hit the building with a violation, because the way I operated and ran the system, I made sure I stayed above the law. So that's pretty much, to sum that all up, is what I was explaining in that video. So for those who want to come at me and say I don't know what I'm talking about, this video, once you watch past this intro, you're going to see pretty much there's a reason on why I can say what I say, and I know a lot more than what most people have been doing for their entire lives. But that's just the way that one goes. So without further ado, let me present to you this video, and sometime shortly after this video, I will have the final video of the commercial grade Scotch Marine boiler, fully loaded gas operation. In some of my videos that I've done on my heating system, I've had some people ask me questions like, why are your radiators on these stands like this? And just to give a little history and insight on this system and why those radiators are up or prompted up the way they are on those raggedy looking stands, this is a system that I constructed over 10 years ago, back in 2005. I moved into this location where I'm at now, which I'm actually will be preparing to leave soon. But in 2005, when I moved into this apartment, it had no heat in the apartment. All the radiators had been removed and taken out of the apartment. Now, for those who are curious in knowing, my line of work currently at this time, which will come to an end very soon, is being a superintendent for a few apartment buildings where I currently am at right now. So they've given me this apartment. So in the process of moving here, or before I even got into this apartment, the previous super before me had told me that the apartment doesn't stay warm and you need to walk around in this apartment with jackets, because that's how cold it gets in the wintertime. So I said, the hell with that. I'm not going for that. And I'm going to go ahead and build me my own heating system. And since I'm a fan of steam heat, I decided to go ahead and install a steam heating system. So that's the reason why you see the radiators off the ground the way they are, because this is a gravity return system. Can't necessarily call it a one pipe. Well, it's a one pipe feed and one pipe return system. So it technically is a one pipe system. But the way I've done it, and this boiler is maybe about just shy of 2 feet high, standing. And I've decided to install this in here, and I got the radiators maybe about 2 feet off the ground from where the boiler stands, in order for the water to return back into the boiler properly. So I'll go ahead and I'll give a brief rundown of this boiler. I decided to go and look this up. This is actually an electric steam mist generator, electric steam boiler. And before I got into this apartment, I did the research. I decided to look up the specs, the square footage, the BTU rating of this boiler, to see what would be for the proper size for where I'm currently staying at now, in order to be able to heat it. Now, this boiler has been in service for over 10 years. I bought it, like I said, back in 2005. This is the 10th winter that it is actually running. This is actually made by Steam Masters. This boiler is actually meant for sauna rooms, commercial size sauna rooms. But instead, what I've decided to do was go ahead and use it for space heating purposes. So normally what you would see in this setup, you would find what you see, the solenoid valve right here, and you can see the opening is actually plugged. I plugged it up back when I first installed this thing, and this would be pretty much where the steam would come out of, and it would pretty much supply steam for steam rooms, and this one can do, I think, over 740 cubic feet or square feet. I think it's cubic feet if I'm not mistaken. And pretty much it would run a section of copper piping into a nozzle that would pretty much just release steam into the room, and then it would supply water as needed. It has a low water cutoff, automatic water feed built into the unit. It has a sight glass. I got to currently clean out the sight glass because it's getting a little dirty, but I'm getting ready to decommission this boiler anyway, so this is getting ready to be shut down. It has a safety pressure relief valve right over here, which, as you can see, I decided to install my steam header on there in order to have, because that's where it has a larger opening, which is a 1-inch opening. The other openings that it has right over here, this is 1/2 inch, and of course you got your pressure troll right over here and your pressure gauge, which I also records vacuum pressure. Let me see if I can get this to focus up real quick. Come on, damn it, focus. Okay, so we can see that it has negative pressure, vacuum pressure, and it has positive pressure. And we can see the dial, the gauge is right at 0 where it belongs. We have the pressure troll here, which I set to 7 psi, 7 pounds per square inch of steam pressure for the system. And that's for the entire system. Now, of course, you don't need that much steam pressure to heat up a heating system, but I decided to put that much in there because the more steam pressure you have, the hotter your radiators get, and I like to get as much heat as I possibly can. So initially, the way this boiler came set up, it came set up with what you see right here, the pigtail, the pressure gauge. Which this is not the original pressure gauge. I actually swapped the original one out for this one because I like to be able to read the vacuum pressure as well. And it had the pressure troll, and it had the solenoid valve, the steam solenoid valve. The circulator pump that you see down here, I installed this on here for draining purposes in order to be able to bleed the boiler out. And since it's on ground level, we know the water, if I run it into a bucket, the bucket is about the same height of the boiler. It's not gonna, the water only seeps its own level. So I decided to put a circulator pump on there. So pretty much whenever I need to drain it, bleed it out, what I do is I click this switch right here, which will turn that pump right on. But of course, I got my hose cock, and then I got a ball valve. And I got the ball valve in a closed position. So that's what I decided to go with. One of the reasons why I put the ball valve there is because these are the only valves I really rock with. I don't mess with any other type of valve. Ball valves are the most, they're the best valves that actually close the water. The problem that you can have with these valves here is that they have a rubber seat on the insiding of them. And occasionally the seat can go bad. And if that seat goes bad, your seal is going to lose. You're going to lose your seal, and pretty much what you're going to have is the valve is not going to close. So as the boiler starts to build the pressure, what you're going to get is water leaking out of the either the hose or the spigot. Of course, in this case, I keep the hose connected. Let me disconnect it just so it's not in the way here. And I only keep it on hand tight because I got the rubber in there. And pretty much I just run this into a bucket and I bleed out the water. Usually I don't bleed all the water out, I just bring it down to about this much because I just want to get what's at the bottom sediment of the boiler. But yeah, I got the circulator pump set up here. I have it wired. I had a friend of mine wire this into a switch. I know a guy who does electrical work, a good friend of mine, actually hooked this up. So just for the record, the boiler has been wired in by a guy that I know that actually does electrical work, because I'm not too savvy on electrical. Not that I can't do it, but I'd rather get someone who's more experienced. As far as the plumbing, however, I did all the plumbing myself. Now, we see 2 lines here. One of these lines I had closed off because it actually, when I was doing some servicing on it years ago, the line, let me see if I can get the light on, it snapped off from the solder joint. So I just never bothered to repair that or replace that line. So this right here is the manual water feed. And then you have the automatic water feed, which I only keep it partially open because I don't need the water coming in there too hard. So pretty much it branches off of one line. This is the hot water line. And I use it and I split it off over here. One goes into the manual, which we're currently looking at, and then we got the automatic, which is always kept partially open. In order for me to operate the automatic water feed, pretty much what I do is there's a switch right here. and that's to operate the automatic water feed. Another one is for the steam solenoid. The middle one right here, steam solenoid. But of course I don't need it because I got it plugged off, so I keep it shut off. And then I have my steam header, which pretty much what you see I did over here. And it's kind of a sloppy ass job, but I did this shit years ago, so I mean I really could care less. And of course I use ball valves for the installation. Probably gotta put some oil on that. But anyhow, I ain't gonna go crazy with this one. Make sure I keep it back in its position. The valves, however, I want to make sure that are working properly is this Harford Loop valve that I set up here. And of course, what you're looking at here is the electrical connection that goes into the boiler. I got a light set up over here so I can see what's going on. And there's these boxes here which are obsolete, they're not used for anything. One of them is a timer that I used to run, but you know that since broke down. But let me go ahead and show you the Harford Loop setup. Alright, so I got my Harford Loop setup that runs right down from the steam main. Of course, that comes through here where it boils up, and I also attached the safety pop-off valve over here also. I had to change this a couple of years back because the original one had went bad. So what I did when I initially got the boiler, I disconnected the safety pop-off valve because it had like some kind of a coupling with the reducer on it, and it was able to fit this 3/4 inch 1 inch by 3/4 reducer, which I just removed, and I put my 1 inch seal on here and then ran my steam main. So pretty much I got the Harford Loop that runs through here, runs back down here, back into the return line, and of course it goes into the boiler. Let me see if I can zoom in on this here for a second. This is not the most, you gotta forgive me, this is kind of a tight space. So as you see right down there is where the Harford Loop ties back into the original return line. And of course you see a solenoid valve down there. That's for the automatic water feed. And that ties it directly into the boiler. And you know, in most cases when you look at your typical steam boiler for steam heating purposes, you're not going to find it set up like that, nor should it be. But since this is not meant for space heating purposes, and I converted it for otherwise, and this is actually a steel boiler, so it means it has a better expansion rate. Cast iron boilers is what you're typically going to find for a residential steam boiler. And the reason why you don't want to tie in a freshwater inlet supply into the right directly into the boiler is because you can actually shock the sections, the heat exchange sections, because you'll have the temperature of the water boiling plus the flame having a temperature of the metal at extremely high temperatures. Then you bring it down to a very low temperature, so that will be an actual shock which can actually crack the heat exchanger sections. But in this case, it's tied into directly into the boiler. Normally how you would find this, it would be tied into the return line. The reason why they tie it into the return line is that way it can actually be the water, the fresh cold water coming back in to supply the boiler with water would be reheated through the return line, because the return line water coming back into the boiler is actually hot due to it being used for previous steam. So here we have the return line that goes back down here, and I got my ball valve set up right over there. And there's a reason why I set the ball valve up over there that goes into the return line here. That's a black elbow. Of course, it's kind of rusted out. Some years ago I had to do some upgrades down here, so it's a tight space to work in. And then I have my Harford Loop valve over here. Now there's a reason why I set this up. Considering the fact that everything is on the same level, some of the return lines, or one of the return lines I have, it actually runs through the ground. Let me see if I can cut this light off for a second. And this one right here, I'll get my drop light. This right here is a return line that runs through the ground. Now this actually runs below the boiler water level. So in cases where this really acts like, in many cases, this can somewhat act like a trap. If you ever seen a P-trap to a kitchen sink, bathroom sink, or any type of drainage supply, that trap pretty much is a U, and it'll hold water into a certain level. So pretty much we always have water sitting in here, and the way that it pushes back in here is through the gravity, because the radiators of course are on a higher level. And right by the radiators I built right where the feed supply and return is at, I pretty much build a larger, or I just kept a larger size pipe just to add on to the weight of the water so it can push back into the return line more sufficiently. So in this case, what can happen is occasionally the return line can get a little rusted, or it can get clogged up with gunk or whatever the case is. So what I did was I created this, I put that ball valve right there on the Harford Loop so I can purge out the line. So pretty much what I'll do is I'll fire out, well, I don't fire it up because it's electrical, but I'll crank the boiler on and I'll let it build up full pressure. When it builds up full pressure, what I'll do is I'll close off my return. Get the light back on. I'll close off my return down here, so that way no water comes out of the return or comes out of the boiler and pretty much drains out the return, or pretty much uses that as an exchange. And then I close off my Harford loop, so that way I don't get no steam pushing through here and making its way into the return line, back into the pump and back into the bucket. Because pretty much if I do that, I'm not going to get the result that I'm looking for. Because what I'm looking for essentially is all the steam that's sitting inside of the radiators that's building up pressure. All that steam I'm looking for to push through the return line, push from the radiators through the return line back up. That way what's doing is, instead of having a water return supply, what pretty much is happening, it now becomes a steam return supply. When you get steam pushing through there, you can clean out all of this bullshit that will sit inside of your pipes and cause clogging. So pretty much what I do is I purge it out by just letting the boiler build up pressure. And then what I'll do is at the last, once it builds up pressure, right before it shuts down, I'll close out my Harford loop, and then I close out, see if I can get a look there, my return line right there. But since I'm not doing it right now, I keep those open. Of course, whenever I do it, I wear gloves because that shit is hot as hell and all that steam is building up, and I'm most certainly am not trying to get burned. So what we're gonna do in this case, I'll cut this light off and I'm gonna demonstrate an operation of this boiler. Since it's electrical, it's very quiet. I'm gonna put on my automatic water feed and I'm gonna turn on, this is actually the switch that will turn the boiler on, and pretty much how it's done is through a heating element. Now I don't necessarily have, and before I even go any further, let me just say this much. This boiler will start to boil water in about 2 minutes. Water will start boiling. That's on a cold start. If it's already hot, it'll boil water probably within a minute to 30 seconds. That's when it'll start boiling water. If I had access to, see, I put a little cabinet over here, but I don't know if I'm able to get that open. If I had access, I'm gonna look at it through this angle here. Move this out of the way. If I had this recessed a little lower, what I would do is I would open this up and see if I can get people to look at the heating element that's inside of this thing. Okay, you hear it's starting to build up, starting to already generate steam. Okay, so over here, this is pretty much how I got it set up. I got my steam header, which is right here. I got my Harford loop, so pretty much it lets any condensation back into the return line so it doesn't build up inside of this. That's the purpose of the Harford loop service, just to balance it out and keep water from getting right inside of the steam main. I got my steam riser. This one branches off and goes into my living room radiator. Goes up here. Of course, the shit looks sloppy because I did it years ago and I just was trying to get it in here. Like I said, it's a tight space, so you gotta forgive me. I got my Gordon's air vent just to get the air out right when it initially starts. It goes up into the ceiling right here. This one goes into one room, which is, actually that's my middle room radiator. And then this one goes and supplies the last few radiators in the apartment. Yeah, I know it looks kind of sloppy. You gotta forgive me. I've done this over 10 years ago, and it hasn't leaked since. That's the most important thing. None of the work that I've done has leaked. Also, let me see. This line here, when I first assembled this system, what I did was I ran with a 3/4 inch steam supply, which was actually a mistake. And what I had was water building up inside of the radiators, and I had an imbalance when it came down to water return line and steam supply, and I was getting a combination of both just chugging inside of the radiators that was causing a whole bunch of problems. So what I did, and this is shortly after I installed this thing, is I went ahead and I got 1-inch piping. Of course, I got my union here, got the header, this shit. Let's see if I can get this goddamn valve to move. You know what, I'm not even gonna mess with it. I'll deal with it another time. And I went ahead and I branched everything off, and I did this whole run, this whole length right here with 1-inch piping. And as you can see, it reduces back down to 3/4 inch right there. That's a reducer. And a coupling reduces back from 1 inch to 3/4. And of course, it rises up. If that remains 1 inch, goes into the valve is a 3/4 inch valve. And then it goes right back to 3/4. So pretty much I had to increase the riser to a larger size to get it to work properly. Now let's go ahead and look at the water gauge. And this thing should start building up pressure probably in about 10 minutes. Like I said, I got it set to 7 psi, 7.5 psi. I really don't need that much pressure, but I set it like that because I want to get, I like to maximize the amount of heat. And that's the reason why I did it. I don't recommend doing it if you don't have to. The most you really need is about 2.5 to 3 psi. But before you do anything, you have to know your boiler, know what its specs are, know how long it, or better yet, your burner, better yet. You have to know your burner and know how long it takes to actually come back on once it shuts off. Some of them have a delay for pre-purge and post-purge purposes. Of course, you don't know what that is. That's a means of providing fresh air into the combustion chamber, so that way if there's any vapors or gases in there from the fuel, from any unburned fuel, you won't have an explosion. So it's a safety procedure. The reason why I went with a electric boiler is because, of course, this building already has its own boiler, but like I said, the radiators were snatched out, and trying to run another boiler as far as fuel and exhaust and all that other stuff, whether it be gas or oil, would have been so much of a hassle, and it's really not even worth it. This was actually the best option. I was able to put this inside of a nice little closet. It really is out of the way. It's very convenient. From what I understand, or from what I know, electric boilers, they're 100% efficient. Not that they cost less, but they're 100% efficient. And listen to what I mean when I say this. They're efficient because 100% of the energy that is distributed into heating the water and bringing it to a boil goes directly into that. Meaning you don't have an exhaust stack where heat is escaping. You don't have a chimney where flue gases and all this other stuff is coming out. All of the energy that's going from the heating element into the boiler is actually going right into that water and is generating steam for the for whatever purposes you're using it for. Of course, in this case, this is for space heating purposes, and this actually heats up the entire apartment. What I'm gonna do, before I go over there, let me say this. The way this boiler is set up, I believe this is an HC18. I think that's I think it's 18 kilowatts, I believe. And that's what they classify it as HC. I don't know, I'm not too sure what that is. I bought this thing over 10 years ago, so I've had it since 2005, and I've had very few problems with it since I've gotten it. A few times I had to replace the motherboard. These are some of the labels that are on here. Of course, this is the low water cutoff / the indication of when it needs to supply itself with fresh water. And once you turn this switch on, it'll automatically supply fresh water into the boiler unit. Now, the way this boiler is built, this box that you see is really not the size of the boiler. This is just a jacket housing. The boiler is actually much smaller on the inside. It probably runs from about this end to probably to where, shortly right where my finger's at. So you have a whole lot of space in here that's actually free spacing. So when you open it up, it actually has insulation on the inside. It has fiberglass insulation, and it has a heating element. Let me see if I can go get this. Hold on, let me get my screwdriver out. You get this open, so I'll let y'all see what the board looks like. Now I have a thermostat wired into the boiler unit, and that's pretty much how I run this system. And as you can hear, it's very quiet, doesn't make any noise. Very rarely will you actually hear it making any noise. The most you're gonna hear out of it is a sound of a soft rumble, and that's the water pretty much coming to a boil. What I'm gonna do here, let it build up pressure, and then I'm going to purge out the line itself. So in a little while I'm going to place my camcorder on a tripod, and I'm going to demonstrate how I do this. I'm going to get my gloves because I'm not about to get the shit burned out of me, because these pipes get hot as hell, and trust me, once you close this door, this door, actually this little door I got right here, once you actually close this door, this room actually gets pretty hot. Alright, so now we're on the inside. This is the board. The most I've ever had, or the most problems I've ever had out of this boiler is I've had to replace this board twice. One time I actually screwed it up when I first bought the boiler and I first connected it. I believe what I was trying to set up some kind of a circulator pump to it, but that shit just kind of screwed up my board. And I've had to have this replaced. I think 2 times I had to have this replaced because I got some chattering out of this. A couple of times it would just start making all kinds of weird noise, pretty much I'm just doing this with my hand, but that's pretty much what I was getting. But just imagine that at a much more rapid rate. And my thermostat is, let me see if I get the light in there. My thermostat is wired. Where did I have it? Oh, right here. This is where my thermostat gets wired up. And I got a guy, like I said, I'm not too skillful with the motherboard and stuff like that. Let me get the light to stay on. So I have a guy from the company come by, did a beautiful job wiring this thing up for me. So pretty much when thermostat calls for heat, it sends the call into this board. The board relays a signal to the boiler, cuts the boiler right on. We should start to build up pressure shortly. But of course, this is the relay. This is when you turn the boiler on, the power comes through here. This is a 3-phase boiler. You see the 3 hots. It comes through here, makes its way, or the relay makes the contact, and it supplies the power into the heating coil. So there's a heating element inside of the other area. I'm going to see if I can try to get that area opened up. But we're actually starting to build up some pressure here. Not much, but gauge is starting to go up. And it doesn't take this thing long to build up pressure. And where I got this thing set up right here, cut this light out. Got this here. This return line runs through here, and as you can see, there's a section where I got it filled in. I did that years ago, and it runs through the floor, runs under the carpet, and then it ties into the other radiators. So I got 3 different connections. Hold on, let me set that right there. So I got the return that ties in from the bottom down here. I got the other one that ties in from this wall here. Of course, it looked kind of sloppy, but I had very tight space to work in. And then I got the return that ties in over here. Now, initially I had this was all 1/2 inch, and I decided to go ahead and expand the size. So this is now 1 inch return. Of course, I wrap my unions with Teflon tape. Once again, it's not the prettiest job. A lot of this this lime and corrosion, this green shit you see on here, this is from pipe flux from when I soldered it, because all this stuff is soldered in. And I just never got around to wiping it down. But trust me, I do much better jobs now than I did 10 years ago. But I decided to expand the size of the return line to get more water flow inside of the return line, because I've had several problems over the years, but I haven't had any problem with this thing probably like out of 5 years with return line issues, because I've set it up significantly to the point where it works. Okay, so you see we're starting to go up on the gauge here. It's not going to take this thing long before it starts making pressure. We're already at about 2 psi, just shy of 2 psi. And the gauge is going to go up fast too, because this boiler, it works very fast. You might actually hear some of the radiators in the background because they work pretty damn fast. Water level usually seeps down to about halfway. So actually it's a little higher than that, so if it drops any lower, let's say if it drops below the halfway mark, that's when the automatic water feed will kick in and start supplying it with fresh water. But I don't think it's going to do it in this case because it looks like it has enough water to run. Now this boiler is an obsolete model. This was a design made back in 2005. They've revamped the design now, so it looks completely different. When I first started looking for this boiler, I got a brochure actually, Steam Masters, like I said, that's the company that makes them. And this one, like I said, does 740 cubic feet. 740 cubic feet if I got the specs down packed correctly. And this one is a triple phase boiler. 208 volts. Yeah, 208 volts. I think it comes from 240 to 208 or something like that. But this is 208. This is the size that I had to get. And you hear that valve in the background venting mildly. So this is, you can hear the radiators in the background of this apartment as well. So pretty much what you get here, like I said, this one does 740 cubic feet. Now there was another one that I was looking at when I was looking at this one as well. This one, I think it's a little bigger than this one, and it does 3,000 cubic feet. That's what it does. The numbers are crazy. All right, so we're sitting just shy of 5 psi. I only had the camera off for about 30 seconds, so I mean, it ain't been long. I'm still getting the screws onto this panel here. I just didn't want to sit there and fight with it and hold the camcorder at the same time. Now that I got it mounted on there, and this tighten this bad boy on. I believe altogether this boiler weighs at approximately about 150 pounds, so it has a little bit of weight to it. So if you're going to carry this thing around, which you shouldn't, you better have your strength game up, because it's not a lightweight piece of machinery. It's a heavy gauge steel boiler. I think the maximum PSI that this can hold as far as steam pressure is concerned is about 100 pounds per square inch. Now this boiler can also be converted for hot water systems. You just have to know how to do it. Me, I can do it because I'm the man. Nah, but all jokes aside. In order to convert it to hot water, what you pretty much have to do, and we're just shy of 6 psi. I'll show y'all in a second. All right. In order to set this up for hot water, you pretty much would have to get an expansion tank. Get a little small expansion tank. But then you gotta have, instead of having the pressure troll, which we're looking right at now, you just pretty much get an aquastat. And then you tie in your circulator pump, and then you're good to go. Fill the system up, you have your manual water feed, and you're good to go. That's how that works. And then you got your hot water heating system. So you can hear the radiators in the background. There's definitely steam going through those radiators. And we're right under the 7-pound mark. I think it goes up to about 7.5 psi, or just shy of 8. I might have to recalibrate it because I wanted it set specifically for 7. But like I said, I'm getting ready to decommission this system, so it's not going to be in use too much longer. This is probably going to be the last winter that this heating system runs. Yep, we're past 7 psi. We're going to a 7.5 psi. I think that's where it's going to stop at. I think it comes back in at 5. Oh, just shy of 8. Wow, I gotta set it back down. Stop, goddammit, what you doing? There we go. So right under 8 psi. Matter of fact, we're going to get a look from the other angle. There we go. Okay. So when the boiler comes back on, that light switch is going to come on. I think that's set to kick it back in at 5. And I'll confirm that once this thing comes back on. There it goes. Now, mind you, let me see. Hear that radiator kicking in. I mentioned how this is a gravity system. Comes in right a little beyond 5 psi. Okay, so I mentioned that this is a gravity system, right? So the water has to come back in through gravity. Since the radiators are not that much higher on your average one-pipe steam heating system, your boiler will be set at a completely different floor level than where I have this one set. So this is set maybe about 2 feet lower than the radiators. So of course I had to build some larger return lines, or thicker, that have thicker mass to just allow more waterway. So I'll go ahead and just briefly show you that. Alright, so y'all seen this radiator before. I did a video on this, I believe it was last year. I changed the air vents since that time. Put a Gordon's air valve in there. It's a little larger, lets it heat up faster. Decided to slap it in there. So pretty much, here's how this is set up. I got the cutoff valve over here, which is a gate valve. The connection that comes from underneath here. You would think that this is actually sitting on a floor somewhere. And I just got the steam pipe coming right in. But no, take a look at the bottom here. It reduces from 1.25 to 1 inch. So I keep everything at 1 inch here. This here is the return line. Then I brought it back down here, which this is all return. And I decided to use steam fittings for that one. I believe it goes from 1.25 back down to 1/2 inch, or 3/4 down to 1/2 inch. And I installed a check valve. Get the light on. The check valve, and then it goes down into the ground, and then that's how that pretty much works. So right over here, you have the, now this is where the feed comes in. I set it up where everything comes in from up above. The steam main runs up top. It comes from the ceiling and it descends down. Of course, I didn't take the time to paint this. I never gave a shit about it once I pretty much set it up. All I cared about is that the damn thing works. And of course, it works. The radiator gets hot as hell. So the steam comes pretty much in here. What it does, the steam and condensated water comes down through here, runs through this L, and your steam, since steam rises, it's going to come right up here. And since water sinks, it just falls back down into the return line. So that's pretty much how this setup is. those of you that want to know what type of radiator this is what you call a cast iron convector. This is made by Governale. I believe it's one of the most impressive cast iron convectors that I've seen. I just think it's a very attractive looking radiator for one that's resuscitated in the wall. So with that being said, we're going to go ahead and we're going to do the, I'm going to bleed out this boiler and show you how I purge out the return lines. So now we're going to proceed with flushing out this return line. Got the camera mounted on this tripod. And here's what I'm going to do. Got that on there nice and snug. Gloves, because I'm not about to get the shit burned out of me, because these pipes are hot as hell. Stay the hell up there, don't move. Light. Door stay open. 5-gallon bucket. Alright. I'm going to take the end of this hose here. I'm going to put it in this like this. Put it in nice and snug. See how I purge out this system, because one problem that I had a couple of years ago is that water would not return out of the return line. So what we're going to do is this. We're going to go first for the return line at the bottom. Close that off. That way no water can come out of the return line or no pressure can push through this, completely defeating the purpose of purging out the return line. The reason why I say that is because if water comes immediately or if pressure pushes back from the return line directly out of the boiler, it's going to shoot right into the pump, right through here. And all that steam pressure that's sitting inside the line, it pretty much becomes defeated, because it can work as a, the steam pressure will always be able to make its way back through the boiler, through this header opening. And that would defeat the purpose of me doing what I'm doing here. So, I'm gonna let this thing come back on. Let it build up pressure. And then we're gonna go ahead and conduct this. We're going to purge this line out. So I'm going to shut off my automatic water feed. That's off. I'll let this thing run a little longer. Manual, the safety relief valve. I'm not going to mess with that too long because that will seize on us. I just wanted to do it for the video. Let this thing go right up around 7 psi, and then I'm going to open up this valve. So we're at 6 right now. Seven. Okay. All right, I'll crack this up. This is how you do this here. And it's going to purge all the water out of the return line back into the bucket. You hear that knocking? The sound of that knocking in this case is actually a good thing, because what it is doing is it means that water is traveling through the return lines, coming, all the pressure is being pushed back from the radiators. So instead of it actually coming from the boiler kick back on, everything is coming back from the radiators into the bucket. In this case, we're gonna pretty much lower the cutoff, should shut the boiler down if it, make sure this thing stays in there. We got nothing but a bunch of steam and water spewing out. Let's turn it this way, I don't want that shit blowing in my face. There we go. Shut it for a second, let it build back up. Let it build up pressure again. Let it go up to 7. No, it didn't go to 7, so that means the water's too low. So if I turn this on, there you go, but we're not gonna run that. That's the automatic water feed. Crack it back open again, do the same procedure. Goal is to clean out those return lines. So instead of actually having a water-filled return line, the steam is actually pushing through the return line, making its way out through the circulator pump and into the bucket. Yeah, I've been doing this for a couple of years. I've never had a problem out of that circulator pump because it's not even on. The pump doesn't get damaged. I have no issue to worry about. And let me cut off the boiler off, and now we will do this. Now that that's done, okay, so that valve is closed. Turn the return line back on, automatic water feed back on. Get these gloves back on. Drop light. We'll start off with opening up the Harford Loop. Start to hear a little of that water coming back in there. Now we're going to open back up the return line. Zoom in on me here. There you go. So now that the return line is open now, it is opening lines back up for water to enter the return lines, which means it reduces water out of the automatic water feed. But we don't need this right now, so, well actually no, what I'm gonna do now, this is the next step I'm gonna do. And this is the final phase I'm gonna do when it comes down to purging this boiler. I'm gonna let it fill up to the point where it can build up another 7-pound pressure run. When we get back up to 7 PSI, I'm gonna close out the, I'm gonna open up this valve and I'm gonna just bleed the entire, I'm gonna flush the entire system out. That's the entire boiler, the return line, everything's gonna get flushed out. I'm just gonna crack this valve open and let it rip. For the record, the water supply that I have going into it, this is a hot water supply. I don't feed or supply my boiler with cold water. As I've said before, if you're running a residential boiler, it is not within the best interest to tie in your water supply directly into the boiler for the water feeding purposes, whether it be manual or automatic. You want to always have it tied in to a return line, because a return line, once that steam gets going, that water is automatically heated. So when the water, even if it's a cold water supply, when it goes back into the return line, it will be saturated and the cold water will be heated, meaning that you won't have a temperature shock and possibly risking damaging your equipment. So you don't want to have that problem happen. Even though I would never have this problem with this boiler because it's a steel boiler, and of course it has a much better expansion ratio than the cast iron boiler. Cast iron is made out of pig iron and graphite and much more brittle metal, which doesn't allow it to have an expansion rate like steel does. But this is a steel boiler, so I don't have that issue. So what we're gonna do here now, let that run up to 7. Of course it's still filling back up, and I'm gonna bleed the entire thing out, and then I'm gonna clean out this sight glass. So just go ahead and let it fill up real quickly. Well, it's already partially filled up. It just needs some. I'm gonna max out that steam pressure. And the only unfortunate part, ever since I've had this this board, the motherboard replaced in this boiler, the last time I had the motherboard replaced was back in 2012. The only problem that I have with it now is when the boiler water feed comes on, the motherboard shuts off the heating element. Before, the boiler heating element would stay on as it was filling with water, so I wouldn't have to worry about the boiler kicking on and off, on and off, on and off. But now when it fills up with water, I gotta worry about it kicking on and off. Okay, so we're up at 6 psi. That's good enough. We ain't gonna go that high. Close this out. What we're gonna do is this. Shut this boiler down. And let this thing rip. See the water's draining out. Now I'm actually purging out my boiler. Get any rust, any sediment that's in there, get all that stuff right out. Just push that shit right out. Then I'm gonna clean out this sight glass. And just for the record, I started to briefly mention or reference a timer that I had at one point in time. I had a timer at one time. Water's completely drained. Just gonna let the pressure die down, and we're good to go. All the stuff is going right into this bucket. And you can hear the steam just pushing out now. Now it's completely steam saturated. All right. So one time had a timer, which once upon a time there it was right there in that box. Now I pretty much just set the system to run on that timer. But the timer gave out some years ago, and I just said, fuck it, I'm not going to replace it. I just didn't care to spend it, because I spent some good money on that damn timer. Alright, we're going to stop this now, because the water's boiling all over the damn place. Let me do this. So I ain't about to get burned. So, I know how to manipulate this just a bit, but I don't want it. There we go. There we go. So I'm going to just let this drain out. We're damn near back down to 1 pound. I'm doing all this with my left hand. My left hand is really not fond of holding a camcorder, so forgive me for the wobbliness. Alright, so we're down to 1 psi. And this is just about done. Just got a straight up steam coming out of there. Now as that's done, once it finishes, lift it up, lift the hose all the way up. That way any water drains right back inside of the boiler, goes back into that tube. And then we're pretty much done with that. Set that in there for now, close the valve off, good to go. So now the last procedure that we're going to do here, we're going to clean out this this sight glass, because there's a little bit of rust on it. I don't like rust on my sight glass. Alright, so the last thing we're going to do, we're going to clean out this sight glass. And of course I keep my spares, I don't know if you can see it, right up here. So in case one breaks, I only got one in there left though, but that's fine. And then I keep my little useful tools, what I use to clean up my sight glass with, right over here. So now let me get this disconnected. Of course I gotta do this without getting burned, so. This thing is rather hot, but I'm taking my chances. I've done it enough times, so this ain't nothing new to me. That noise you're hearing is a vacuum, not steam pressure. I'm gonna run some hot water through this just to kind of get it cleaned out. I'm gonna soak this, saturate this with hot water. And I always keep this brush on standby whenever I deal in these situations. make sure my rubber washers are still intact. Keep the brush nice and hot. The water is hot. And then pretty much how I do this, take this like this. Put it right in there, and that usually gets enough of the stuff out. Now you can do this with some WD-40 or some other kind of cleaner, but usually, you know, as long as you don't let the rust sit there for too long, because if the rust sits there for too long, what it does is it'll eventually stain the glass, and you won't be able to get it out. But usually if you do it maybe once a month, which in this case, I don't have to, because this I don't get that much corrosion in the system. So I'm good to do it once every couple of months. I'll do it maybe 3 or 4 times a winter. But in big buildings or bigger systems, you might want to have to do it more consistently, depending on how often you have leaks and how often your boiler has to fill it with water. But you know, pretty much go about doing it like this. And another reason why you want to saturate the brush, one of these nylon brushes, in hot water, because the hot water makes the brushes more flexible to the point where you can actually push the brush through. Because in certain cases they're kind of hard and you can't really push them through because it's it just doesn't have any flexibility. And, you know, then when it's all said and done, I usually just take a little rag, a little piece of toilet tissue, just dry it off, and then give me a second longer, and we will reinstall this sight glass back onto the boiler. Alright, so we're going to put this brush back in its respectable place. It's easily located. And we're going to get this back in here. You got to be careful whenever you do this, because you can damage the glass. Now, I say this much. If you have an automatic water feed on your boiler, and for whatever reason you happen to accidentally damage the glass, in that case you're just going to have to trust your automatic water feed. And if you don't have a spare glass to replace it with, what you want to do is close off these valves so that way no water leaks out of it. That way you can at least still run your boiler. Now you start off with this. And of course I got to replace the rubber on this this sight glass, because they're actually worn. So you want to make sure you get it in nice and evenly so it catches evenly on both sides. Then you start off by hand tightening it. You don't need to go too tight with a wrench. You just want to kind of snug it in there. Make sure it's good to go. Same thing at the bottom. Of course, there's a tight space to work in because I got this return line sitting right here. Then you want to attach your shields. And this is pretty much to protect the glass. That's what these rods serve the purpose of protecting that glass, so that way the glass doesn't get cracked. And say you happen to be working in the area and you got tools swinging about, and that's the purpose that serves. So now with that being said, we're going to turn the automatic water feed back on. I can turn the boiler back on if I want to, but it's not going to come on. That heating element will only come back on the minute water fills back up in the boiler. Alright, so we're going to put this brush back in its respectable place. It's easily located. We're going to get this back in here. You got to be careful whenever you do this, because you can damage the glass. Now, I say this much. If you have an automatic water feed on your boiler, and for whatever reason you happen to accidentally damage the glass, in that case you're just going to have to trust your automatic water feed. And if you don't have a spare glass to replace it with, what you want to do is close off these valves so that way no water leaks out of it. That way you can at least still run your boiler. Now now you start off with this. And of course I got to replace the rubber on this the sight glass because they're actually worn. So you want to make sure you get it in nice and evenly so it catches evenly on both sides. Then you start off by hand tightening it. You don't need to go too tight with a wrench. You just want to kind of snug it in there. Make sure it's good to go. Same thing at the bottom. Of course, there's a tight space to work in because I got this return line sitting right here. Then you want to attach your shields. And this is pretty much to protect the glass. That's what these rods serve the purpose of protecting that glass, so that way the glass doesn't get cracked. And say you happen to be working in the area and you got tools swinging about, and that's the purpose that serves. So now with that being said, we're going to turn the automatic water feed back on. I can turn the boiler back on if I want to, but it's not going to come on. That heating element will only come back on the minute water fills back up in the boiler. I was going to let people get a look at that heating element, but you know, in order to get all this stuff out of here, right behind here, because the heating element is located right where those vents are at. You see the bolts, not the screw, the bolt, but the screws. The heating element is located right inside of there. But in order to get that out, the access panel that I have only comes up this high. So, I mean, I really don't, that's just not going to work. So, I mean, maybe when I take the boiler out in its entirety, then we'll be able to get a closer look at it. But I'm not about to do that until I'm ready to decommission this thing. Now, just on another note, when you first put your sight glass back in there and fill your boiler up with water, the water's going to come back in there rusty. That's nothing that you need to be concerned with because that rust will eventually make its way back to the bottom and the water will be clear. You just got to let it do its thing and you're pretty much good to go. Give it a couple hours and this water will be clear as the tapping water that comes out of your sink, depending on which state you're from. That might not be a very good thing. But anyhow, to close this video out, once again, I gave you a rundown of this boiler. Sight glass, low water cutoff / automatic water feed tied into one, or indicator for automatic water feed. The solenoid for the automatic water feed is behind the boiler. Back here, lights come on, and you can see the solenoid right there. Then you have the solenoid. You have, I don't know what these compartments are, but there you have the return line shutoff valve. You have your Harford Loop shutoff valve, your header shutoff valve, the circulator pump, or the pump that I use to drain out the boiler if I don't want to go through firing it up with all this pressure. And then you have your switch, steam solenoid. Since when I'm running it, it stays off, and since it's blocked off, it stays off. Pressure gauge, set to 7.5 to 8 psi, which I probably will lower down. Then you have your pressure troll. Well, not the pressure gauge, but your pressure troll is set to 7.5 to 8 psi. Former heat timer. Well, not a heat timer, but a timer that I use to turn this thing on and off, which is no longer in service, so it's done for. And then we got the lights. Bathroom radiator. This is one of the last radiators that receives steam in the apartment. Tied into a one pipe line that goes, which is a steam main, which also acts as a return for this radiator. You got your 1-inch cutoff valve, your 3/8 air valve, number 43 Hoffman. Once again, Governelli cast iron convector. Why? Because I like them so much, so I decided to install 2 in this apartment. One in my bathroom and one in one of my rooms. Another cast iron radiator. This is actually the rear. This is the radiator in the rear room. This is the last radiator in the apartment. I believe altogether I have about 5 radiators, steam radiators tied in to this boiler. We got the Hoffman valve air vent on one hat on the rear end of the radiator, and then we have a gate valve on the front end of the radiator. We got it sitting inside of a cabinet. Actually, this one is not the original radiator that I had back here. I kind of swapped out several radiators in this room. And this also ties into the bathroom as well. So both of them are tied into the same steam line. You hear the damn thing's running right now, so it might be kind of late in the day for it, but it's still a little chilly outside, so heat is still needed from time to time. In this case, we're running just a bit. I'll let that valve pop open one time before I close it out. And there it is. And of course, I have my panel radiator right down here. So with that being said, I'm gonna get ready to close this video out.